Great, thank you very much. Okay, the final speaker in the session is Alessandro Blasame, who's at ETH in Zurich. He's a senior researcher in health ethics in the Health Ethics and Policy Lab at ETH Zurich, and his research focuses on innovation in biomedicine and its ethical, regulatory, and political consequences. So, Alessandro.
Thank you, Paul. And it's a great opportunity to be here this afternoon in front of such a terrific audience. And it's really great to be able to speak about systemic oversight to you. Systemic oversight is a governance concept that FIVN and myself have developed in a recent publication. I will give you details later on. It amounts to proposing high-order guides as to how to design oversight mechanisms for biomedical research conducted with big data. So here is the menu of the day. Here. I will first describe how the health data ecosystem is evolving. I will then illustrate some of the challenges involved in this process, and then explain how systemic oversight might be able to help addressing or fixing them. So, progress in high throughput technologies has brought biomedical research in the era of big data, well before big data became the other B buzzwords, actually. And of course, this does not only apply to genetic information, because other biological substrates can be interrogated through high-throughput technologies and produce huge amounts of medically relevant information. But if you look at this very popular rendering of the idea of precision medicine, you see that genomic data and microbiomic data are, together with other data types, that describe, for example, environmental exposures and behaviors, or even data that are contributed directly from the patients. So actually, there is a certain ethical and regulatory uncertainty as to the status of precisely this kind of information that is now being integrated with genomic information. And these uncertainties are relative to a number of issues, such as the quality of ethics review for the collection of this data, informed consent, data access, sharing, and data protection conditions, and also how privacy can be maintained across these various data types. Now, the presence of these types of data is due to a bigger phenomenon of digitalization in medicine. We've been collecting electronic health records for a while now, but there are new elements that are kicking in, and Jean-Pierre exposed some of them at the end of his presentation. There are mobile technologies in particular, coupled with very popular commercial app, that actually allow people to collect increasing amounts of data about themselves. There are smart scales here. There are portable glucose measuring technologies. There are smart pills and other wearable devices, like this is an FDA-cleared wearable thermometer, for example. What is interesting is that all these devices track something over time. Now, due to this, actually, the patient is starting to be seen as a repository of information, information that creates what some people are calling now the digital phenotype of each and every one of us. Now, but there are also new technological capabilities that are entering this space, and artificial intelligence is one of them. I just brought up this example here of a very, very recent publication that I read a few days ago. Now, this is a deep learning algorithm that not only does what algorithms are known to be able to do, therefore classifying lung cancer from histopathology images in this case. But also, what this does is to make genetic predictions using deep learning just by looking at the histopathology slides, so without touching DNA at all. So this is telling you that genetic information appears, in this case, in a context in which we would not expect it to be. And therefore, in light of these very interesting trends, I think we can look at the at health data in terms of an evolving data ecosystem that is made by standard sources of data, as we know, coupled with expanded sources that include environmental, lifestyle, and behavioral data, including data collected through mobile devices. And to this corresponds a broader array of technological, analytical, and regulatory capabilities that need to be in place in order to collect and to process this data. And an even broader array of stakeholders that are now entering this space, even though we're talking about sometimes stakeholders that were not supposed to be in the health space at all, like app developers, for example. Now, let's see some of the challenges here. Actually, this is the way in which this is one way in which we could look at the defining features of the ecosystemic of this health data ecosystem. Uncertainty here refers to uncertainty as to the real purpose of data collection. So who is using my data and why is not actually very clear in the moment in which that data gets collected in the first place. So what uses are authorized and permitted is not always very clear. Who controls and who owns the data is not clear either. And especially it's not clear how oversight of these uses can be occurring. Expanded temporality relates to the fact that data are to be stored and used for indefinite amounts of time, always possibly also exceeding data subjects' lifespan. And actually, while the data are being in use, the access condition to this data may or may not evolve over time. And what is going to evolve for sure is that new capabilities and new technologies will enable new and unforeseen uses of the data. Relationality is the third feature here. This is something that people working in genetics are very familiar with, because we know in genetics that data reveal relations among data subjects, but also big data reveal relations between data subjects and their environment, their habits, their behaviors. So in a nutshell, big data encourage classificatory practices by grouping people according to specific characteristics. So this corresponds to a number of challenges, especially when data are not collected inside the healthcare setting or through medical devices. Sometimes there is no consent, sometimes there is no ethical oversight, and sometimes it's even harder to protect this data and to promote data sharing. Regarding data sharing, we published this paper earlier this year. This is work done about 1 year ago, in which we wanted to look at what is that all the available guidelines on data sharing are indicating to be the policy needs in this area. What we did here is a comprehensive review of more than 200 guidelines, international guidelines that span the last 20 years. This is just the study design. I won't go into any detail here. But what we found here is that, interestingly enough, the policy needs that are most frequently highlighted by these data sharing guidelines are the three here: data quality and curation, autonomy, that means informed consent, and privacy. Now, this is hardly surprising in and of itself, but what is more surprising is how unevenly distributed is the emphasis on these various policy needs. And this fragmentation actually is even more apparent if we look at how different types of organizations think about what is needed to promote data sharing, and you have it here. So you can look at numbers in the paper. This is just a graphical way of convening this idea of fragmentation. Now, also based on this, we were thinking that to reduce policy fragmentation, we need oversight mechanisms that should converge towards the same direction. And to tackle the emerging challenges that I discussed before, oversight mechanisms should be able to adapt to the ecosystemic features of health data. Of course, there are no ready-made solutions in this area. Especially, there are no solutions that apply across the board. So we try to come up with this idea of systemic oversight here. So we first introduced the idea in this paper published last May in the Journal of Law, Medicine and Ethics. And the idea here is that we would like to foster an ethical common ground for a variety of governance actors and activities, and to promote sort of a distributed model of accountability throughout the ecosystem. To achieve this, we will have to adapt both the composition, the mandate, the operations, and possibly the scope of relevant oversight bodies. Now, the systemic oversight governance model is based on 6 components or building blocks that are clustering around the different challenges that I discussed before. So let me go briefly through each of them really rapidly. So adaptivity, to begin with, amounts to the capacity to be ready to deploy proper oversight mechanisms for new types of data. We're seeing that there are new types of data becoming relevant to health research. Flexibility instead refers to treating data under different oversight rubrics according to their actual use. So, for example, data types that are not regarded as ethically sensitive in the beginning may become sensitive if used in a novel way. And this is the case, for example, of mutation prediction in the artificial intelligence paper that I showed before. Monitoring, the other pillar of systemic oversight, refers to the ability to detect the emergence of new vulnerabilities for data subjects, linked to the use of new types of data or to new analytic capabilities with data that we already have. So these kinds of vulnerabilities are the usual suspects here: discrimination, privacy harms, but also the risk of being surveilled 24/7 thanks to these mobile devices that collect data about us all the time. Responsiveness has to do with the ability to prevent those vulnerabilities from actually resulting in actual harms, and also to ensure effective containment of harms should they occur, for example, in the case of privacy breaches. Now, reflexivity instead has to do with monitoring the effects of classificatory practices as they emerge, and especially to be able to scrutinize our own assumptions as researchers when we set a research plan. And inclusiveness refers to upstream engagement of relevant stakeholders, in particular those that are typically underrepresented in research. Now, where we are with the development of this idea, basically we have done the first 2 columns here. We have analyzed the ecosystem, we have proposed the building blocks, and what we are doing now is trying to study whether now existing oversight mechanisms and bodies relate to the 6 components of systemic oversight. Of course, here we are also testing our approach, and in particular, and I'm closing with these 2 examples, we are testing this approach in 2 currently ongoing projects. One is about an innovative data aggregation and governance model that will supposedly improve data availability and increase individual control on data. And another is a project that has to do with technological innovation in data protection, and in particular, it's the project that we have together with Jean-Pierre. This is the first project. So it's an MS pilot study in scientific terms. So basically, the project aims at creating a machine learning-based personalized prediction on multiple sclerosis progression. And it does so, and this is the interesting feature perhaps, on patients that are aggregated on a platform that is called MeData, which is a cooperative. It's a data cooperative in which the data subjects are also members of the cooperative, and therefore, as in any cooperative, they get a right to vote and actually to participate in the governance of this tool. We have described the model a little bit in this publication, but what is interesting for us is that we want to test governance tools that are meaningfully aligned with systemic oversight, especially as far as these three dimensions of oversight are concerned. The second project, as I anticipated, is DPPH. I don't have to say much more about this because now you know a lot about it. But this is a platform for developing data protection technologies that is based on a distributed architecture and uses blockchain-based smart contracts. So it's a form of disintermediation to allow data access. Now, what is interesting here for us is to observe the impact that this has on participants' consent and rights, the impact that disintermediation has on the role of ethics and oversight bodies, and finally, how can we ensure that we have in place trust building and accountability mechanism in a process that is mainly and to a great extent, as Jean-Pierre just said, based on the absence of trust among the different nodes. And this one is actually very much focused on these two dimensions, monitoring and reflexivity of the model that I have presented. So with this I'm done, but before I leave the floor, I would like really to ask you to get in touch because we need other experimental setting to test the governance concept of systemic oversight. We are more than willing to collaborate with people and institutions and research groups. So don't be shy, please come forward, and thank you very much again for your kind attention.